Good morning, everyone. Thank you for coming to my presentation on high accuracy data collection. So we're gonna quickly just run through an introduction. Most of you, if you're already using Collector, should be pretty brief. I really want to kind of focus more on the demonstration that I have. I think that I'm doing something kind of new. I've done this presentation before, and I felt this might be a better way to demonstrate high accuracy than trying to do a live demo here. So I'll get to that when we get to it. So we're going to go through just a quick introduction, getting started, and then we're going to go over some considerations before you start a high accuracy field data collection, what things you kind of want to pay attention to, and information you might want to gather from external resources. We're going to go through, and then the second and third items we're going to go through for the setup and the field data collection are kind of be wrapped into one through my demonstration. And then we're going to do a QA at the end. So how is Collector being used? It's a pretty versatile application. So we work with customers that have more obvious data collection, but some that are maybe less obvious. Like we do, obviously field asset maintenance through collection and data maintenance. Through Collector, you can pretty much configure through your feature service how you want to collect your data. If you want to capture just new features, you want to just do update existing features, or if you just don't want to do any geometry updates, you can limit it to just doing attribute updates. So it's really just, you can tailor it for your particular field application so you're not capturing data when you didn't intend to or deleting data when you didn't intend to. Field capturing of observations, attachments, whether or not it's a file locally on the device through maybe you've already captured photos, or you're taking it directly through Collector. And what's really good is kind of along the same lines of the demonstration I'll be doing is more like rapid assessments. In my case, it'll be more of a damage assessment. So it's really good for being able to get out into the field. If accuracy is a factor in that assessment, which in my case it is, you can spin it up really quick to be able to demonstrate that. Asset inventory. You can improve accuracy and currency of data. And currency, by this case, is updating its location. A lot of times you may be working with data that's been GIS but not GPSed. So maybe it was digitized from paper maps. So now you're sending the field crew out to update the locations of, say, your manholes or your water valves, and you just want to edit existing features. You don't really necessarily need to drop features, and you want to maybe add related tables for inspections, and they want to just go out and capture that information. Another common workflow is UAV ground control. A lot of times we work with users who want to use Collector to capture ground control points to feed it into other apps like Drone to Map, to where they want to use those points to tie their aerial imagery together so that they got their aerial photos from their drone mapping. And then hydrant collections, another workflow that you can utilize Collector for, again, using it for hydrant inspections, again, capturing new features. And it's a modernized field workflow. A lot of times, at this point, many users have already migrated their data from paper maps to digital maps. This is a kind of just more of a natural migration pattern through Collector because it's kind of built into all of ArcGIS. You can just leverage all this data and services you already have if they're editable into Collector already. So, all right, so getting started, kind of getting more into the meat of what I want to get to today. And some considerations now to kind of think about going into a data collection. Now, first of all, when I say high accuracy is just like a relative term we throw out there, right? That can vary from person to person, right? So somebody may need sub-meter. That's high accuracy. In other words, when accuracy is a factor in your data collection workflow, would be considered a high accuracy workflow, right? Where it's not just whatever my phone gets. It's something I actually have to control, maybe sub-meter, centimeter level, whatever the case may be. Or maybe you're working from project to project and your accuracy may vary, right? So maybe if you're more consulting-based projects, you may be, okay, this month I work on a project that is more maybe working for building footprints. I don't need centimeter level for that. Maybe sub-meter will do. But maybe the next month I work on a project that does, right? So those are the kind of things you might want to consider, or if what you have will work for all your projects. So, and then the supported receivers. On Android and Windows, those aren't so much of an issue with supported receivers. This is more geared for like iOS. iOS is more strict on what receivers that they support. And I'll get into that a little bit more. There's a whitelisting process that manufacturers have to go through for iOS, which is why when you look for a receiver, you want to make sure it's supported with iOS if that's what you're planning to use. So something to consider there. Correction services. That's kind of a big one. So obviously for any successful field data collection workflow that needs high accuracy, you want to first have an idea of what type of correction service you're going to be using. If you are in an area of good cell coverage and you have a base station, say you already have it through like a DOT, or maybe you have your own base station that you want to connect to, then that should be a problem. That should be, which is what I'm going to demonstrate in my demo, is how to configure a connection to a base station through a cellular connection, because I have one. But if you don't have one, maybe that won't be a good option for you, because you want to look for more of a subscription-based service that's a satellite-based correction service. A lot of the GPS manufacturers offer subscription-based services that you can discuss with them. That way you're not limited to cell coverage. Would be something to kind of think about too. And then datum transformations is another big one. If you're using a base map, say an Esri base map that's WGS84 Web Mercator, and your correction service is a NAT83 2011, then you're going to need a datum transformation in collector in order to not introduce datum shifts. If you're hesitant on applying datum transformations into your data, then maybe consider using a base map that is of the same projection of your correction service. So therefore, there's no need for a transformation. Things to consider, again, I'll go into this a little bit more in a moment. So we work with a lot of different vendors, a lot of different receivers. Many of these, if you haven't been over to the booth, we brought a lot of these with us if you want to take a look at them. There's many models, and every vendor has different types. We brought just a few of the ones we got. But these range from consumer grade, which is going to be like maybe sub-meter level, meter level, to survey grade, right? So there's a lot of different variety in this space. Also, when you look at receivers, you want to look at the mobility side of the receiver. How am I going to be using it? Am I going to use it pole mounted? Am I walking through rough terrain? Do I need an all-in-one handheld? Do I want something that I can just hold in my hand? All those considerations take play in the workflow. So, and all these different manufacturers offer different solutions for that. So real-time differential corrections, I kind of already touched on this, but I want to go into it just a little bit more here. Obviously, we know it improves accuracy from your receiver, because those real-time differential corrections, as opposed to post-processing, when you do it back in the office after the data collection, is by the time the feature is added to the map, it's already been corrected, so there's no need for post-processing back in the office. It removes all the errors that are introduced, and there's at least a half a dozen different types of errors that can be introduced into a measurement, which is why autonomous or just regular GPS isn't a surefire way to get good accuracy. So they require a subscription and/or a connection to the receiver. As I mentioned before, if you're in an area of stable cell coverage and you have a base station to use, oftentimes those GPS manufacturers, they'll have their own apps that you have to configure the connection client through their app, and then that feeds into collector, which is what I'll go through. But like I said, if you're not in an area of good cell coverage, and a lot of these companies offer PPP type services, which are subscription-based services. Like, for example, Trimble uses RTX, which is you purchase based on what level you need. There's different levels of accuracy based on your subscription level you want. There's other ones like Atlas. There's a lot of different ones you want to research in, if that's an option. They can still be used over cell, but they also have the option of just based on satellite. So you're not limited to say, oh, I can't use it because I'm not in cell coverage. So again, the third-party app is where you configure the connection to the base station or the correction service. Now, the last point is where you need to understand your map's projection. This information is what you have to bring to the table based on if you're connecting to somebody else's base station, that information should be known to you about what datum they're using. Most of the time you're going to find it's NAT83 2011 if it's in the US, but it could be something different. I've used base stations in the United States that are WGS84, right? It's not as common, but it can happen. So you want to kind of just be aware of what it uses so you know how to set up your datum transformation. Because even though most receivers internally use WGS84, you're capturing on the correction service. So that is where your data is coming from, not from the datum of the receiver, of the service. So that's why that's important in this case. So datum transformations. In a workflow, say from field to office, there's many places where datum transformations can be introduced into your data depending on how you set it up. What we're going to be entailed with, and I'll go through some of these, but is a DT1, datum transformation 1 is the one we're going to be concerned with here. But the other ones are datum transformation 2. So in ArcGIS Online, when you add your data into a web map, there's a transformation that happens there. If it's not Web Mercator, if you're using your own base map, if you want it to match the data you're adding, there's a transformation that happens there through ArcGIS Online. And then obviously on your database side, if you're working in, say, a ArcGIS Pro or ArcMap, and your datum is set to a different transformation than projection than your data, then there's going to be a transformation in your data frame, right? So you got all these different areas where transformations could introduce shift. So as long as they're set up correctly and they're using the right transformation, it should be fine. It's just, this is just kind of just to be aware of where those could happen. And one thing I wanted to kind of show you, I'm going to kind of take us out of here for a second, is I know probably a lot of you are familiar with this. You guys pretty familiar with this? You've seen this before? PDF. One thing I wanted to point out, which is probably already obvious to those of you who have seen it before, let me kind of make this just a little bigger, and this is kind of how we set it up. So this isn't the transformation we're going to be using, but just to kind of give you an idea of how transformations are set up. They each have their own area of use and accuracy associated with them. So that is how we determine your list of transformations when I'll go through it and I set up my location profile. So you have to choose what area you're at. If you're at the world level, you're going to get a slightly different list than if you're more focused into, say, California, right? Because that is going to give you a more refined list. And then we order it based on the accuracy of those transformations. So where you choose your transformation depends on the list we give you. So we basically leverage this type of setup in our app. So just to be aware of, and also on the point of transformations, is that they do have their own accuracy associated with them. So even though we say high accuracy and your receiver may be capable of getting you down to a centimeter, but if you're using a transformation that's only accurate to maybe 10 centimeters, that's where you're accurate. That's where you might see on offset. So something to consider when you choose a transformation is what maybe is the best one to choose. We try our best to give you the best one, but maybe if it's not ordered correctly, maybe there's a better one to use. So just something to be aware of. This PDF, for those who aren't aware, this is in the ArcGIS desktop documentation. There's just a link to this PDF file. And this is the 10.6 one. This was just recently updated, but they have older ones for different versions. But obviously, you're going to want the newest one because this has the most up-to-date information. Okay, so now we're at where I want to be. So for this demonstration, I'm going to do a damage assessment workflow, and I'm just around Esri's campus in Redlands doing this demonstration. And I'm going to be doing a combination of point and polygon collection. I'm using a Trimble R2 that's pole mounted, and I'm going to be using an N-trip connection to Esri's base station. So we're going to go through that whole workflow, and I want you to kind of see that it's easy to set up, but sometimes accuracy doesn't play with me. So I have to kind of continually switch my required accuracy level, and we'll go through all that, and I'll go through how I set up the profile, and then we'll go through that a little bit more. So let's kind of get right into it. There's no sound, so I'm going to walk you through it. So here I am, Esri's campus. This is me outside with my receiver. I have not yet configured the app, so now I'm going out of collector into the GNSS status app, which is Trimble's app. I'm going to set up my Bluetooth provider to my R2, which I've already paired to the device. I'm just setting it up in here. So there's my connection. So I set it up, and at this point, okay, so I'm just getting estimated, which is autonomous. I'm just GPS. So now I want to go and set up my correction. I already have under server settings, this is my N-trip connection to my base station. So I have it set for primary as internet, secondary is uncorrected. You can see I already have my URL and my port and my N-trip source set to my Redlands base station. For our base station, if you're even in the area, you can use it because it's a public base station, so I don't have password and login information. So I don't need that. So here I am, now I've set it up. Now I'm just going to kind of take a look at the details in the status page on the Trimble app, see what I'm getting. So I'm getting my satellites, I see I have my primary data source, but I don't quite yet have a fix. So I'm going to go back to the home. Now I got my N-trip connection, which is good, but my accuracy isn't. So there you go, I got 7 centimeters. But it's going to bounce around. Usually in this area, I get 7 centimeters on this device. It's a sub-foot device. It's not a centimeter device. So, but you can see it was at like 5 o'clock in the afternoon, and it was a little overcast this day. Even though I was in a good area, it was still not really cooperating with me. So now we're in collector. Now I'm going to set it up in here. So now we're going to go through and set up the location provider, which is basically I want to choose the Trimble. I already have it paired, set up in their app. Now I got to set it up in our app, in the collector app. I'm not concerned with elevation at this point, so I left my antenna height empty. There we go. Paired to the Trimble. And now we're going to go and do the location profile. So our base station uses NAT83 2011. So I'm going through this. I'm typing in NAT83 2011. I'm going to choose that as the correction service datum. Now I'm choosing my map coordinate system, which is in Web Mercator because I'm using the World Imagery base map. If you're using one that is matching the correction service, you may not need to do this step because you don't need a datum transformation. I am because I do need one. And after we're done with the demo, I'll show you kind of, I actually went through this using not using a datum transformation, and you'll see the shift. So you can kind of see what happens. I'm choosing my area of use to roughly my area. It doesn't have to be down to your exact location, just roughly in your geographical area. We order the list. I chose the top one, which is ITRF 2008, WGS84, ITRF 2008 to NAT83 2011, which is the most accurate one in my location. So I'm just giving it a meaningful name. So because if you have a lot of these, if you go to different areas or if you use different base maps, you may have more than one. And then now you have to choose that. So you add it to the list, now you choose it. This is the one that I want to use. All right? Now I'm going to set my required accuracy. I'm going to set it down to 10 centimeters. And then I'm also going to use 95%. I'm going to pause it right here for 1 second. Let me go back a little bit. So 95% confidence. This particular setting, a lot of our customers require accuracy reporting to be at 95% confidence. By default, which is an industry standard, we use RMS, which is a 68% confidence interval. That's what I would be using. We basically apply a factor to your accuracy values. So then if you're like, okay, I'm getting 1 centimeter, but then you turn this on, hey, now it's like 3 centimeters. That's because it's gonna show worse, but you have a higher confidence that that's what you're actually getting. So if you're working for an agency that actually considers how the accuracy is reported to you, this is a setting you might wanna use. There's other ones like 2D RMS, 3D RMS, there's a ton of other ones, CEP, there's a bunch of other different ways, which are basically just calculations that we perform to show you the receiver accuracy. So that's why I'm turning it on, because I want that for this particular project. So let's continue. And you'll know that you're using that because in the map, if you're familiar with doing this in Collector, you see that we have that badge in the bottom, in the corner where you tap and it expands. It shows you next to the accuracy what you're using. It'll say RMS, it'll say 95%. You'll know that you're using that from the field. So I'm turning on continuous collect. I'm not doing averaging at this point. Well, I'll come back and I'll turn on continuous collect for my polls. So now I'm in the field. I'm gonna get my accuracy. There I am. That's kind of if you're not, most of you probably are not familiar with Esri's campus. So, well, I'm going back into the status app. I'll come back to that. So I want to basically just monitor my accuracy. Obviously this is terrible, so I'm not going to use this. So what I'm trying to point out here is that even though I got an N-trip connection, I'm talking to my base station, but my accuracy is not very good. So I'm waiting for it to kind of spin down a little bit, which is some of the challenges you might face when you're doing this. Is I'm waiting for it to drop, and drop, and it goes up, but it will go down. See, it's going down. Now it's going back up. So you guys are waiting just like I was when I was out there freezing. Because even though it's California, it was like 50 degrees and I didn't have a shirt on. I was wearing like a golf shirt, which had like a breathable shirt. And I'm like, oh, they better like this presentation. So there we go. Like I said, on a regular good sunny day with this receiver, which is obviously, we obviously know we're going to get good accuracy in a good open sky area. This receiver usually gives me 7 centimeters, and it usually is stable at 7 centimeters. So I get it, but it won't stay there. You'll see that the best I'll get with this project at this time of day is 12 centimeters, which you'll see. So now there's me. I've walked over to my location where I want to start collecting. So I'm going to do a damage assessment basically of utility light poles. So inside that planter box that's kind of on the edge of our parking lot, we have a lot of light poles. I'm basically going to just be capturing those. But before I do that, see right in this particular example, let me actually go back a minute here. I'm going to kind of point something out. So here you can see, whoop, stop. Okay, so I set my required accuracy to 10 centimeters initially, and you can see in the bottom right, my badge is red, which means I'm not getting that. The best I'm going to get at this time is only 12 centimeters. So that's not going to work for me. So what I'm going to do is I got to go back and up that, because I can sit there all day, but it didn't work. I was there for like about an hour outside, and I never got a consistent 7 centimeters. So I go, well, it's time to just bite the bullet and up it. So now I'm going to go back and say, hey, I can't start collecting because I was a little too ambitious with my required accuracy settings. So I need to kind of curve that a little bit. So I'm going to go up and I'm going to increase it a little bit. In this case, I'm just going to put it up to 30 just to account for any, if it goes to 12, sometimes it goes to 14. That way it's not such a hard cutoff. Here we go. Got 12 centimeters. I'm green. I got a fix. I got RTK float. It will get an RTK fix eventually. And then I'm going to start doing a stream using my polygon. So I'm going to, first of all, I'm going to capture the area of the damage assessment that I want to perform. So we're going to go ahead and choose my polygon. I'm going to do streaming. Okay, I started my stream. I'm going to drop it down to 1 second intervals. And then we're off. There we go. No, I did speed this up. You're not going to watch me walk for 15 minutes. So when it gets to a point, I'll be like the Flash, and it'll be like, boom, done. So, and I actually just ran that fast just for you guys, okay? So you can see my accuracy is pretty consistent at 12 centimeters. Again, open sky area, it's pretty ideal. So I'm there, I'm done, boom. So I'm getting to the end of my polygon here, and I'm going to go ahead and close it up, throw in some notes, and then get that submitted. And I'm going to take a photo so you'll be able to see where I was walking. It's on a bike path. So there I am, taking a photo. There's all of our cars. You can see the light pole by that car on the right. That's kind of what I'm going to be capturing next. So we'll go ahead and take that, and we'll drop along, submit that. All right, so that looks good. Now we're going to move on to doing some damage assessment for the poles. There's only about 5 of them. Normally I would be like boom, 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 click, 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 but I want to make it slower so that nobody loses me here. So I'm going to switch on continuous collect because a lot of these are just going to be repetitive. I might change the amount of damage that the particular pole has, but on average it's the same type of data collection. So I'm using continuous collect for those who haven't used it. It's really helpful if you're doing a lot of monotonous repetitive work and you just want to copy attributes but update your locations. It's really good and really easy to do that, especially if you have a lot of attributes. In this case, I don't have a whole lot of attributes, so I could have just filled them out, but I wanted to show that this is actually a much quicker way to do it. So there's me, I'm walking, I'll speed it up and I'll just flash over to the pole that I'm there. And then I'll get to the next one. There we go. Accuracy is still holding at 12 centimeters, which is good. That's what I want. Now these, so see it climbs, because a lot of these poles can be under a canopy. So you see those trees there? So they're not all, so even though the area I walked was, a lot of these poles are kind of covered by trees. You can see my accuracy is climbing, 87 centimeters, one meter. So I'm getting all this feedback, right? So there's one damaged pole, there we go. Yeah. In this particular case, you could use Siri. You can just use the mic to talk into it. I just typed it in, but you're right, it's a good point. You could have just talked. If you're doing a lot of typing, or if you're using a small keyboard, you can just talk into the mic and it will go to words to text. So we go here, we're gonna go to the next one. Then I'm gonna kind of speed it up because I don't want to run out of time here. But for the most part, I think you guys are getting the point. Let me go to the next one. And I'm gonna speed this up. We're gonna go really fast. I'm gonna go through all these, all these, all these. And I wanna get to one that I wanna show you, which is the last one. So we're gonna collect the very last poll, and I'll do an overview of everything I did. Okay, there's this one. Okay, there we are. So at this point, I've collected all my points that I wanna collect. But I wanna redo this last one. Well, not this particular one, but I want to redo one of my last ones that I did, my second to last one, which is that blue one. So I'm going to go ahead and delete that, and I want to update it using averaging. So here I am going through my metadata. So I have all the metadata fields turned on. You can see I got my accuracy, my lat, long, altitude, all my PDOP, correction age, number of satellites, fixed time, all that. The averaging fields are blank because those only are relevant when you have averaging enabled, which is what I'm going to go through next. So we're going to turn on averaging, and we're going to do that. So I deleted that because maybe I'm unhappy with it, or I want to just test out averaging, see if it's better. So let's go turn on averaging. So I'm going to bump it up to 10 locations. Default is 5. Back. All right, I'm going to walk over there. I think I speed it up. There we go. Hey, this is my first go at video editing. Not bad, right? You guys aren't? Right? iMovie works if you guys never used it. It's a good way to edit videos for free on your iPhone or iPad. So you can see in the upper left corner, my locations are counting up. So there we go, I dropped it, and then I'm gonna go through and I'm gonna submit it, drop some attributes, and then we're gonna submit that, and I'll go through the metadata, and I'll show you how those are populated. So we'll cycle through the metadata, and you can see some of those are not relevant anymore because they'll be populated down lower. So you got average horizontal accuracy because we're taking into consideration all of those positions. We also capture standard deviation, which is a good measurement to indicate how your cluster is because we don't show you the point cloud. So if it's, that's a topic in and of itself. If you have a question on that, let me know afterwards, but we do capture that. All right, I think we're good. So let's go back. I got a minute and 40 seconds. I can get you guys done. All right, we've gone through that. So as a recap, we went through location provider. It has support for integrated receivers, which is the default receiver, the built-in. Bluetooth, which is what I was using, or on Windows, we support serial connections. You can connect to a named receiver. You can specify your antenna height if elevation is a factor. Whitelisted providers, again, I went through that a little earlier about the process whitelisting takes, which is basically Apple. The manufacturers are whitelisted with Apple, and then in our app, we have to whitelist their device. So it's both ends. We have to actually get their receiver supported. Location profile, we kind of set that up. I'm going to go through this quick because we already did that, but I do want to show you my next slide. I went through this again just for demonstration purposes to show you when I was not applying a correction profile. I was showing you, see, here's the shift. In the southeast is the shift. So that is about 1 meter. So that's when I didn't apply my datum transformation. This is a kind of, now you can see like, hey, everything's consistently shifted. I didn't do a datum transformation, or maybe I chose the wrong one. So that's kind of what it would look like if you got it wrong. We went through accuracy. I'm going to kind of skip through these. I want to go through another slide. We kind of went through these, averaging 95% confidence. Field collection, we went through the GPS badge. I showed you, I expanded it. We do support overzoom. So if you're only cached to a certain resolution, we do allow you to go further than that. We resample it so you can see a cluster of points if they're really close together. We went through metadata. Okay, now, what's new with Aurora? I didn't want to demonstrate Aurora because it wasn't fully baked in, but who is already in the beta? I guess it'd be more. All right. So current and upcoming. So this is specific to high accuracy. Obviously, there's a lot of good things in this, but we support grid-based transformations in Aurora. We don't in the current version. So if grid-based transformations are what you want to use, we do support that. What is coming is support for z-values and vertical datum transformations. That's kind of a very complex, head-hurting topic that we go through and try and phase out how we want to roll this out through ArcGIS Online, through the runtime. We have to get support for all of that. So that's going to be coming. Please sign up for the beta if you're not there. It's great. We like to get your feedback through the beta community. Me, myself, and my coworkers, we frequently visit that site. We get pinged an email when you guys log something. It could be something as, hey, I got this problem, or hey, this is great, but my workflow requires X, Y, Z. Even that feedback is what we want, because this is active development. Best time to get us that feedback if there's something on it that you like or like a wish list item. All right, so that's about it. Any questions, you guys? Sorry, I know I kind of ran a little over, but sorry. All right, I know if you guys have to leave, feel free to take off. If you have questions, just hang around. So, sure. That goes to the geodatabase. So his question was about the metadata storage. That's written, those are well-known fields that's in our doc, and those get stored in your geodatabase. So, correct, if you needed to do anything about that, correct. But then your metadata values may not be updated. Those are going to be tied, those get written only with GPS collection, not with manual point collections or anything like that. So if you update it, then yeah, so. That's a good question. I want to say probably yes. We store EXIF information with the photo. I don't know how that is retained. If you say extract the attachment as like a JPEG, that would be a good question. I don't know. Exactly, yes. We do have a lot of people that like to be able to bring attachments out of their blob fields and store them like locally in a field. We do have, I didn't show it here, but we do allow you to rename your attachments. So it's not, they're all image one, image one, image one if it's on iOS. So you can rename it before you submit it, which I didn't show here, but you can. So. Sorry, I know I got to get out of their way, but if anybody has any questions, I'll be right over there, or just hang back and we can chat outside here. Cool? Thanks, guys.